Hello guys, welcome to another episode of Math Time, and today we'll be going over basic trig ratios. And I thought it would be best to go into trigonometry now because we've already done Pythagorean theorem and distance formula, and those all have to do with triangles. And trigonometry is just the relationship of triangles, finding their measurements, how they relate to other objects and shapes. And before you start to do that, you need to know all of the different things to do in trig and the three basic ratios. Now, when I draw a triangle, there are three things. There's some things you need to know. If I have a trig ratio, let's say, okay, first let me show you all of them. There's sine, which is written down as just sin, cosine, which is just cos, and tangent, which is just tan. And they all mean different things. And when they're written down, let's say I have sine, they'll have sine and then the angle that it's at. So if let's say that this angle right here is 20 degrees. Let's say it's 20 degrees. It would be sine 20 if I wanted to find the sine of it. Now sine is represented as opposite over hypotenuse. So let's say the length of the hypotenuse here was 5. And let's say that the opposite. Now, what is the opposite? The opposite is the side that is not touching the angle. This side right here is adjacent to the 20-degree angle, but this side right here is opposite. So this would be the opposite. And let's say that this one is 4. So if I wrote this down, it would be 4 over 5. Because 4 is the opposite of this angle, and 5 is the hypotenuse of the entire triangle. So let's go a little bit further. The next one you have is cosine. So let's say I have the cosine from the same spot. Cosine of 20, because it's 20 degree right there. What would this be? Well, cosine is described as adjacent over hypotenuse. And we already talked about the adjacent. The adjacent's the side touching it. So let's say this is 3, because that's what it would be if it's 3, 4, 5. Remember, we talked about that. So, this is a weird triangle, but just ignore that. It's not really to scale. It's just to give an example. So let's say that the adjacent 3, we'll have 3 right there, over the hypotenuse, which is 5. Hooray. And now finally, tangent. Tangent's the weirder one, because it's, once you get into later videos, you'll see why, but tan. Tangent is described as opposite over adjacent. So let's say we have tangent 20. Yeah, it's a 20, sorry, it's really messed up. The opposite of this angle is 4, and then the adjacent is 3. So the ratio of tangent for this angle in this triangle is going to be tangent 20, 4 over 3. That's it. So now I'm going to show you how to use it and how to use them. And the thing is about these, you're really only going to be able to solve them with a calculator unless you want to go through rigorous just tables. It's going to be a lot easier to do it with a calculator. I'm just going to use my phone calculator. It's right next to me. But let's say I have a triangle, and these are not to scale at all. Let's say I have a triangle, and I have a 30 degree right here. 30 degrees, so that would be 60, and this would be 90, because it's a right triangle. I have this, and I want to find, and let's say that we don't know what my hypotenuse is, and we don't know what this adjacent side is, but we do know the opposite side of the 30. We're going to use the 30, so I don't even know why I wrote these down. We're only going to use the 30. So let's say I know the opposite side of the 30, and it's 5. Well, I can't really use Pythagorean theorem right now because I don't know what this side is. So that's where trig ratios come in. So the obvious thing I can do here, I have my opposite and I have my hypotenuse. Even though it's not represented as an actual number, I know that is something. It's x. So since I have my opposite and my hypotenuse, I can go sine 30 and then the ratio. So it's going to be 5 over x. And now if I actually wanted to solve this for x, I just multiply the denominator. Boom. And now it's going to be x equals 5 over sine 30. And hopefully this works. And let's go. Where's my calculator? There it is. So actually, I'm going to put this in Wolfram Alpha. And so the way we're going to know that this is at least somewhat right is this number should be a little bit larger than the 5. So let's do it. 5 over sine 30. And I got 10. That's cool. So x equals 10. And I know that 10 is definitely greater than 5. So this answer is reasonable, which is always good. So that is how to solve with basic trig ratios. If you have any questions regarding this kind of stuff, please let me know, because I'd be happy to answer them. Thanks for watching. See ya.